Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. We're going to start the new chapter, new concept, new idea. We want to solve the system of linear differential equations. We have already done this solving the differential equation of higher order. We have done this differential equation homogeneous, non-homogeneous. We'll apply all these methods in solving this system of linear equations. We need it to solve for the system of differential equation, all these ideas. Also need the concepts we have studied already in our course of linear algebra, and for that one you can have the quick revision for that one already given in my previous videos. I have the videos in the educational network, and you can find there the Kramer rule. This is my lecture 14 that we need to solve the system of linear equation. Then we need also the solution of system of equations, that's from linear algebra, that was lecture 9. Then we need in differential equation the homogeneous and non-homogeneous differential equation of higher order, that is 2.2, lecture 2.2. So you can just have a look on that one. That will help you to understand it better. So we come back to our lecture. This is our chapter 6. Our lecture in our series is lecture 12, part 1. We give the introduction. So if we have one equation, there's an equation, and there is more than one equation, we say the system. Here there are more than one unknowns. For example, we have the unknowns x and y. We have two variables. It means we need two equations to find the complete solution of that one. So we are having x and y. So because we are having the differentiation, so there will be a variable which is independent variable. So we say our independent variable is t. I give an introduction. We take here dx by dt plus dy by dt is equal to 3x plus y. The second equation I have dy by dt plus 2x plus y equal to 0. I have the variable x, y and t. So x and y are my dependent variable, t is my independent variable. So you say my x is a function of t and my y is a function of t. So that's the idea. So we can write this equation in different form. For example, I just take all the variables on the right hand side. So I can write here this is my dx by dt minus 3x plus dy by dt minus y equal to 0. And here we can have 2x. So first we write x and then we write y, dy by dt minus y equal to 0. Moreover, we can just simplify this one, that our dx by dt we take as differential operator and we write as d. So this one I can write here dx minus 3 plus dy minus y equal to 0. And my second equation is 2x plus dy minus y equal to 0. We can rewrite this one and we can write in a different way. We take x common and we write here d minus 3. I can have here d minus 3 into x, d minus 3 into x, and then we write here y common, we get d minus 1 into y equal to 0, and get here 2x, and then plus we write here d minus 1 y equal to 0. This is another way of writing my system of linear equation in operator form. Even we can go further and we can just write in a matrix form. I can write here the matrix form. This is my d minus 3, d minus 1. I have here 2, I have d minus 1. And then I have the matrix xy, the column matrix. And here right hand side we have 0. We can write this in a matrix form also. And this is a matrix form. You know that we are using the linear system of linear equation, right, in the matrix form, in the equation form, and using the inverse matrix to solve that one. So these are all ideas we are having a system of linear equation. I just give the introduction as a note for the system of linear equation. We are having here the system as a11x, a12y is equal to b1, and we are having a21x plus b21y is equal to b2. a21y is equal to b2. So we are having here, these are the system of linear equation, not differential equation, but above we discussed the differential equation. Then you know we can take the coefficient together. We say here this is coefficient a11, a12, a21, a22, say a22, and then we are having the unknown matrix, that's my xy, then we want to find the matrix of constant, this here b1 and b2. So here we can write this is equal to a, the coefficient matrix, this matrix of unknown, and this is my right hand side b. So if we say our right hand side b is equal to 0, we call this equation as homogeneous equation. This is non-zero, this is non-homogeneous equation. Similarly, we can write this one as, this is my differential operator d, the matrix, and this is my x, the unknowns, and this is matrix 0. Sometimes mostly is written as L as the matrix, and we can write L x equal to 0. And if the right hand side, we have, for example, I have the operator dx is equal to f. This is non-homogeneous. Or we can write here instead d, we can write here lx. Lx is equal to L is the differential operator, and x is the matrix of unknown, and f is the non-homogeneous part of that one depending upon t. So we say we can have this. So we will be coming across such equations, and this is a very general form of that one. So I give you another form where we write in operator form. So here is my example 2. We directly write the operator form, or we write here equation 1 to write an operator form. We get here, I am going to give you the second order differential equation. I have here d2y by dx by dt is equal to x plus y plus 2t. This is my equation 1. My equation 2 is 2 dy by dt. Then we are having here plus minus d2x by dt square, and we are having here plus 4x is equal to 3. So these are my equations, which is my two equations. I rewrite these equations and keeping the values x and y on the left hand side and the other than x, y on the right hand side, and changing the operators. I say my d by dt is my operator d, differential operator, and d2 by dt square is my operator d square. So I can write this one. I get here d square y plus we are having 5d. We take x on the right hand side, y on the left hand side, and we get here 2t. And here we get here 2 dy by dt minus d square x plus 4x is equal to 3. Now I rewrite this one, and as I always taking that x on the first variable and then y is the second place. So I take here this with x, we get here 5x, 5d x minus x plus d square y minus y is equal to 2t, and here I get minus d square x plus 4x and plus 2d y is equal to 3. I rewrite this one. I can take here x common. I get here 5d minus 1x plus we take y square common, y common, and get here d square minus 1y is equal to 2t. Similarly, I can take x common in the second equation. I get here 4 minus d square x plus 2 dy is equal to 3. Now I write this in the matrix form. So I can have the coefficient of this one is equal to 5d minus 1. I have d square minus 1. I get 4 minus d square and 2d. Then I am having here the unknown, matrix of unknown is xy, and matrix of the variable, dependent variable and constant, we can write like this one. So this, as I explained you before, is a non-homogeneous differential equation. We can write here Lx is equal to f, is function of t. So what's my L? L is my differential operator, the matrix form. My x is where matrix of f is my matrix of constant. We say there in the case of the we take b, but here there are the variables depending upon the dependent variable, independent variable, or some constant. So this is the idea we are having here. So as I mentioned before, that we are going to use the methods we have discussed before in our linear algebra course, also in differential equation course. So we are having this whole file with you in YouTube, on our channel. That is, our channel is the educational network, and there are in linear algebra we have the Kramer rule. We are going to apply that one to solve the problem. I give this short introduction, and then we are having the elimination method to solve the system of linear differential equation in linear equations. And in differential equation we have the method that's homogeneous, higher homogeneous differential equation and non-homogeneous differential equation. You need this one to understand this, and please why those TVs are, you just the lecture notes are given also in the description. You can take from there and study it so that you can understand it completely.